As you know, AI is being slammed in our faces wherever we look. So let's make the problem worse. Here's how to run AI at home. Let's talk about what we really need for AI. Graphics cards. Not all graphics cards are created equal, and we will need a card with large amounts of VRAM and high memory bandwidth, along with good software support to run AI. We should probably get this out of the way first. Some graphics cards, mainly AMD below 6000 series and nvidia below 1000 series, are much too old and lack proper driver support for running modern AI. We found this out the hard way by buying a pair of Tesla K80s which are now door handles. Also note that the nvidia 1000 series tests the V100 and Titan V were recently deprecated but still work for modern AI when using specific driver versions. You should also note that across the board software support is generally better on nvidia cards with CUDA than AMD cards with ROCm. However, that's not to say AMD cards won't work for running AI. Moving on, another point is that AI speed is greatly limited by memory bandwidth, since we have to shift data from memory to the GPU to generate content. Now you may be thinking that buying graphics cards are insane VRAM bandwidth like the nvidia H100 or A100, so we can run AI quickly. Okay, that's not an option, let's look at some consumer cards. We first started running AI on the nvidia GTX 1660, but we quickly realised that the 6GB of VRAM was very limiting when it comes to model sizes and context lengths. We realised we needed something bigger. We went on eBay, saw an nvidia Tesla K80 24GB. We made the terrible mistake of buying prehistoric e-waste. After that, the RAM shortage happened, so we sold some RAM, got a pair of Tesla nvidia V100 cards for dirt cheap, and they run AI much better. Do note we got the SXM version, and used SSM to PCIe adapters to make them work. This is janky but an effective workaround to make data center cards work properly with normal computers, and is not recommended for space, noise or power conscious users. If that's not an issue, however, these are extremely powerful cards with 900GB a second of memory bandwidth and excellent VRAM capacity of 60GB or 32GB. These cards also have good software support until they were deprecated recently. It still works with specific driver versions, some links for that are in the description. We currently run a Discord bot with all manner of tools and do some training on them. Generally you want a graphics card that is the size of your model in billion parameters or larger, but for most this is not feasible with top tier cloud models. Such models have great performance but you need a lot of VRAM, and I mean a lot of VRAM to run them. Top models like GLM5 or Kimi K2 take several hundred gigabytes of VRAM to run. So let's dial back a bit and operate in the realms of what we can actually run at home. For a 16GB graphics card you can easily run a model that's about 7 billion parameters in full precision FP16. But 7B parameters can be very limiting as the model can be too dumb or just not manage to talk at all. Let's talk about filtering larger models into smaller cards. We don't actually need full precision to run an AI model. We can learn precision, but it will also learn the quality of the model. This is called quantization. By quantizing a model, we are making the numbers smaller, less diverse, so it takes up less space. A well-quantized model can fit in a much smaller VRAM space relative to its parameter count. For example, GPT-OSS20B, which we run on our nvidia Tesla V100, has 20 billion parameters, but using a good dynamic quant, we can fit it in 16GB of VRAM, leaving room for 120k context. These details are set up in the description. With the theory out of the way, we can tell you how to run AI at home. We'll start with the simple way on Windows and then move on to Linux, where we'll tell you how to get better performance and more control. For Windows we have various options, but we will choose the program Ollama for running AI locally. Ollama is a simple and intuitive app that provides a chat interface and various AI models for download. Let's start by looking up the download for Ollama for Windows. Click on the first link to the Ollama website. Download the installer. It comes pre-packaged with all the relevant files that are needed to run AI on a GPU. Run the installer and click install. Do note this may take a while and that it requires several gigabytes of storage space. Once that is done, go ahead and close it and launch Ollama. Welcome to the Ollama app. It resembles a modern AI website similar to ChatGPT. Over here next to the chat box there is a model selection with many options. For our purposes today we'll be using Qwen34b. You can choose any model that fits on your machine. Ollama automatically downloads the model for you. Depending on the model size and your network speed, this may take a while. The model will automatically load and start responding once it's downloaded. Now that we're done with Windows, let's move on to Linux. We're going to start by running sudo apt add repository restricted, which gets the repository with all the NVIDIA packages we need. We will now run sudo apt update and sudo apt upgrade to get the new packages. Now we'll run this sudo apt install to get all the packages we will require to run AI on this machine. As always, the commands you will need are in the description. Next we will run the command ubuntu-drivers devices to look for the drivers for our GPU. As we can see in the suggested various NVIDIA driver package, we will use the latest version of timer recording 590. Let's install the NVIDIA drivers, CUDA-toolkit and nproc for our GPU. Now we will reboot to load the driver. We will now download the resources for our AI inference software of choice, Llama-cpp. This program is a good choice for running AI models at home due to being open source, easy to use and very well optimized. On Windows, you can simply download the package from Windows with CUDA from the GitHub releases. For Linux, although there are packages for Ubuntu, you may have to compile the program yourself. This is not an issue and we'll now show you how to do it. Let's move into the llama-cpp directory and set up for compilation. We will use cmake with a few flags to configure it. For our system, the exact flags for this command are in the description. Now we'll run cmake again to actually compile the program. Do note this may take a while and will max out your CPU. It took several minutes on our Threadripper 1950X. This is normal and expected, just be patient. Now we're done compiling, let's leave llama-cpp directory. We will now make an AI directory to hold the programs in our AI models. We will now move over the program executables of interest into the AI directory. Let's now move into the AI directory and download our models. For demonstration we have chosen Qwen34b thinking. You can choose any compatible GGUF model that fits on your machine. We will run wget to download it. As always, the links in the description. We will now run llama-cli with the -m argument to specify our model file. Here we can see a llama-cli. We can now use commands in plain text to talk to the model. The commands are explained on the screen. Now let's go back and do the llama-server. We will run llama-server with -m argument for the model once again, and the host and port arguments to configure and access the web UI. As you can see, the web UI is quite similar and main feels similar to talking to ChatGPT.